Nuclear energy. Atoms are tiny particles that make up every object in the universe. There is tremendous energy in the bonds that hold atoms together. What is this energy? Is it useful to us? How this energy can be obtained? Let us understand the answers of these questions. Energy in the core or the nucleus of an atom is known as nuclear energy. The bonds which hold the atoms together contain a massive amount of energy. When atoms split or fuse together, nuclear energy is released. Nuclear energy can be freed in two ways. The first way is nuclear fusion, in which the nuclei of atoms are joined together or fused. When the nuclei fuse, they form a new element and release the excess energy in the form of fast-moving neutron. The Sun, like all other stars, creates heat and light through nuclear fusion. In the Sun, hydrogen nuclei fuse to make helium and during the process release huge amounts of energy. The hydrogen bomb, humanity's most powerful and destructive weapon, also works on the phenomenon of nuclear fusion. The second way by which the nuclear energy can be released is nuclear fission, during which the nuclei of atoms are split, causing energy to be released. Enrico Fermi first experimented with nuclear fission in 1934. Uranium isotopes are normally used as the fuel in nuclear fission because of the large size of the nucleus, and it is easy to split. Uranium nuclei can be easily split by shooting neutrons at them. Once a uranium nucleus is split, multiple neutrons are released, which are used to split other uranium nuclei. This phenomenon is known as a chain reaction. We have been able to harness nuclear energy and regularly use it to generate power, which is also called nuclear power. Presently, nuclear energy provides for approximately 16% of the world's electricity. Thus, nuclear energy is produced naturally and in man-made operations under human control. Nuclear power is created in nuclear power plants, which are specifically designed to withstand the nuclear fission process. At a nuclear power plant, nuclear fission occurs inside a nuclear reactor. Inside the reactor is a core, which contains uranium pellets. These pellets are stacked together inside fuel rods. Here, uranium atoms are split apart in a chain reaction to create heat. Heat in the reactor is controlled with control rods made of boron, which absorb neutrons. When the rods are lowered into the reactor, they absorb more neutrons and the fission process slows down. To generate more power, the rods are raised and more neutrons can crash into more uranium atoms. The controlled chain reaction gives off heat energy, which is used to boil water in the core of the reactor into steam. This steam turns the turbine blades, which generate electricity. The condensed water returns back to the core to be reheated, and the whole process is continued. Nuclear energy has a lot of advantages over fossil fuels. Nuclear power plants need a very small amount of fuel to generate energy. 1 ton of uranium produces more energy than is produced by several million tons of coal or several million barrels of oil. Coal and oil burning power plants pollute the air. Well-operated nuclear power plants do not release pollutants such as carbon dioxide and sulfur dioxide, so they do not contribute to the greenhouse effect or acid rain. However, the biggest disadvantage of nuclear energy is the storage and management of dangerous high-level radioactive waste. Disposal of this radioactive waste has not been safely achieved. At present, the most dangerous waste is sealed in glass-like blocks, which are buried deep within the stable rocks. Careless disposal of waste in the past has led to pollution of land, rivers, and the ocean. A nuclear reactor always functions at a high risk. Despite a high security standard, accidents can still happen. The consequences of an accident would be absolutely devastating, both for human beings as well as for nature. One type of reactor disaster is known as a meltdown. In such an accident, the fission reaction goes out of control, leading to a nuclear explosion and the emission of great amounts of radiation into the environment. There is also possibility of proliferation of nuclear materials and potential terrorist applications for making catastrophic nuclear weapons such as the atomic bomb. The nuclear power plant is very expensive to build and to safely dismantle afterwards, which is called decommissioning. Construction of a large nuclear power project can take between 5 to 10 years, which leads to time and cost overruns. Uranium, which is the main fuel used in nuclear power plants, is a scarce resource, and its supply is estimated to last only for the next 30 to 60 years, depending on the actual demand. Thus, if used with caution, nuclear power can be an important contributor to sustainable development. But to make sure we have plenty of energy in the future, it is up to all of us to use this energy wisely.